very good one for the arteries and the vein. Okay, so remember the arcuate, okay, and then the segmental. And see these dots over here? What do you think those represent?
Glomerulus.
So those would be your, actually, technically, I think they're referring to it as the renal corpuscle because
Includes the
remember
Bowman's
it's the
capsule.
Bowman's capsule plus the glomerulus inside. So you have the renal corpuscle there, and you see the cortical radiate, but I think in here they still call it the interlobar or interlobular arteries. So it's just in one of those models, I think they mentioned that. Now, you recall that as you enter the the glomerulus, or yeah, you basically go through the afferent arteriole, right? And then inside the Bowman's capsule, that's where you'll find it. So we'll focus on that later on here. But again, I just wanted to stress that the glomeruli would be mostly found or typically found in the cortex, right? So that's why when I show you the slides later on, you will know definitely if you're in the cortex or in the medulla. Okay, so in the medulla you're mostly going to see just tubules, but when you're in an area where there's the glomerulus, it's very distinct. It's so easy to detect which one's which. So you know that you're going to be in the cortex if that's the case. Okay, I think that's pretty much it here with this one because we went over some of those here as well. So let's take a section. You remember the renal pyramid, right? And the tip is the renal papilla. Okay, so this gives you a very good depiction of the cortex and the medulla and the structures that we would find inside. So it's just getting closer and closer so that we can magnify the glomerulus later on. So once again, when we see the cortical radiate artery branching into the cortical area, you're going to find that it's going to go, basically it's going to go into the afferent arteriole, so the blood's going to go in here, and then inside you find the glomerulus. And one way that you can detect which one is which is, if you notice, this is the one that's branching off from the artery here, right? So that means that's the afferent arteriole because it's heading into, right? Because it's just coming from the larger artery. And then you know that this is going to be the efferent because this is the one that's going to lead to your peritubular capillaries. And again, we said earlier that this is where the gas exchange will take place. That's why you didn't see a color change here, but instead you see it here in the peritubular capillaries. And if you recall, they basically are like a net that's been thrown, to cover the whole area, and that's what keeps the tubules vascularized, because those tubules are made up of singular cells that line the tubules of the nephron. Okay, so basically, you're going to have the blood reach back to these veins, right? And then eventually it will drain out. Now, if we follow remember the process taking place here? Inside the glomerulus?
Filtration.
That's filtration. So the filtrate would actually enter your, not yet, hold on, Bowman's capsule first, and then the PCT, the proximal convoluted tubule. See how it's all twisted? And we know that it's a proximal convoluted tubule because that's the one that would stem off from the Bowman's capsule. Right after the Bowman's capsule, you have a proximal convoluted tubule. And then, see how it's going down? The descending limb of the loop of Henle, and you have here the thin part of the descending limb, and then you have the ascending limb of the loop of Henle. And up here, see how you have more convolutions? So you're going to have the distal convoluted tubule, and then you're going to have your connecting tubules, and then your collecting duct. And here, see how this will lead eventually to your minor calyx? You remember that? Okay, and that's the one that's going to get drained out. Now, when we look at the slides, I want you to remember this and imagine how when you have a slice of this, regardless of what way it was sliced, you should be able to visualize that because there are convoluted tubules, you're going to see some parts that seem like they're circular, and some that seem longitudinal. Okay, just because of the orientation. This is a three-dimensional structure, so you would expect that. Okay, and I'll show you that when we look at the slides later on. But I just want you to picture this so that you can imagine why they would look like the way that they would look like in the slide. Okay, now if you look closer here, so this is a giant model of your glomerulus, okay, and your Bowman's capsule. So again, together they're called the renal corpuscle, okay? And so see here, you have the afferent arteriole, and then you enter through into the glomerulus. So basically what happens is the fluid in here will get filtered out because of, you guys, are you okay?
Blood pressure.
Okay, so yeah, so the hydrostatic pressure will basically leave or cause some of the fluid to leave, and as I mentioned, it's about 20% of the fluid gets filtered. Now, as it leaves, it's now going to be called filtrate, and again, we follow the pathway of this one already earlier, right? So it goes out through the efferent arteriole and such. So the filtrate then will eventually leave the Bowman's capsule and enter eventually your proximal convoluted tubule, okay? Which brings us to this next model.